hard to leave easily, right? Kamil mentioned at the opening how easy it is for us now to access solutions provided by cloud service providers. We have a multitude of services, everything needed to meet our needs. And that's nice. But the difficulty arises when we have to manage the deployment of these services in the correct order. And that's exactly what orchestration is about. So I'll briefly explain what orchestration is, what problems it solves, and what best practices are used in creating such orchestration. And I'll also show a case study of one of the clients, how it looks from the perspective of such an architecture. So, what are the challenges we face with orchestration? Let's imagine the multitude of services we use. We adapt them to specific needs, whether it's data replication, computation, or powering models. Well, soon it turns out that we have 5, 10, 15 services performing various tasks. And at this point, we see that the complexity is quite significant. And additionally, we usually have some unstructured workflows that trigger something somewhere. On the side, there are scripts that trigger something with parameters. Sometimes someone goes on vacation and it's completely unclear why something didn't work. We then arrive at a lack of visibility. We don't see what's happening because there's chaos in these workflow structures. We don't know what errors occurred, where they appeared, at what stage, and what happened that the data is missing. It's hard to maintain any reliability in these types of flows. It's difficult to maintain. And so we arrive at the difficulties in scaling. How do you scale something that is a script maintained somewhere written in Python? And there's no centralization of such things. So how do you tame this chaos? And so here we come in with data orchestration, which is a certain process, an approach to automating our entire stack, meaning the architecture we've seen several times today. From the moment of acquiring the data through its transformation, feeding, and final consumption in BI. Quite often we notice the comparison of orchestration to ETL or ELT, which is not entirely correct, because ETL or ELT are examples of data, flows, our data pipelines, whereas orchestration is the process that manages how this pipeline is executed. So what are the pillars of such data orchestration? The first 3 are really the foundation of what orchestration is. Firstly, it involves planning or responding to business events, which means designing how we want to initiate the entire data processing. Next, we have the workflow, which refers to the specific tasks that are carried out within our pipeline. Launching a service, verifying the status, checking data quality. All of these are tasks that make up this workflow. Next, we have dependencies. Dependencies mean building relationships between tasks within the workflow and tasks across different flows. This means that these tasks are able to communicate with each other. In one workflow, we are able to see what happened in another workflow and respond accordingly. Moving on. Equally important is exception handling and retries, which means catching what happened in our pipelines and responding to such an error. In that case, we repeat the task. If such an error occurs, then we must stop and do nothing more to avoid making a mess in the reports at the end. Moving on to monitoring, which is the ability to see in real time what is happening in our pipelines on a daily basis. Where we are, where specific data is being refreshed. Do we expect that the report will be available, or have these errors occurred? Scalability has been mentioned multiple times today, and from the orchestration perspective, we also need to be ready to scale the refreshing of our data. This is not only from the perspective that the solutions we manage are scaling themselves, but also from the orchestration perspective. We can influence the tasks executed in parallel, meaning that a service prepared once by the architect and engineers can be launched with parameters to scale multiple times within this pipeline. And finally, parameterization, which is the ability of this pipeline to run with different output parameters. So we can orchestrate these pipelines in such a way as to launch them with specific parameters. For example, to simulate the data loading process, because Something happened along the way and it was unavailable. We want to execute it again to load our data warehouse, but we can't just launch it like that. We need to pass some parameters. So why is this orchestration important? During the break, I was thinking about this slide because these are things that really overlap significantly with what was discussed earlier. So I thought I would talk more about a real-life case, a client's case. There was a company X that struggled daily with sales results. Services were being sold, but there were also retention issues and a significant loss of customers. It wasn't a catastrophic situation, but the management was concerned, so a report was created for them. As you know, there's one table with 10 data marts underneath to show all the necessary results. And then a new month arrives. The management looks at the report and oh my, we don't have a loss. We're not losing customers. Finally, the trend is reversing. Everyone is pleased. You can hear champagne being opened from the office. But then, 3 hours later, the analyst has a heart attack. Because it turns out that one of the data marts didn't refresh along the way, and we do have losses after all. And this is precisely the situation where we realize that orchestration is one of the answers to how to ensure that such situations don't occur. How to ensure that these pipelines are executed correctly, and ultimately to have that value, which is the properly prepared and published dashboard. So how to orchestrate? There are a few good practices that I wanted to present. These are not all of them, but these are the ones we most frequently use when implementing orchestration. Firstly, a holistic approach. When approaching orchestration, even though it appears at the end, meaning we already have the services we want to orchestrate, we should think about it from the beginning. This means that when building the architecture, when creating the solution, we should already know how we want to manage this pipeline, which errors we want to defer, how we want to orchestrate, and how to respond to these situations. So a holistic approach causes us to look at the entire architecture from above, planning our actions. Secondly, a process-oriented approach. Orchestration is a process. Therefore, it's worth utilizing our capabilities and skills in how we design processes. It's worth thinking in terms of processes, taking care of inputs, outputs, and exception handling. So, as if we were designing a typical business process, but really focused on execution, mainly or entirely within systems. Equally important is testing, which means embedding in our pipelines through orchestrating tests that can be run to verify whether our data meets the rules we've set, whether the keys match, and whether the values are as they should be. Many tools now provide the capability to generate tests within the pipeline. So we embed tests as part of generating data transformations, and then we can make use of them. And if not, we also have many external tools, such as Great Expectations. We can embed such a tool within orchestration and respond to what happens if we don't meet these rules. Further, the mentioned dependencies, meaning building dependencies between tasks, not only within a single workflow, but also between different workflows, so that these things communicate with each other and the dashboard refreshes only when all the data marts underneath have been refreshed. Automation of workflow creation. Many tools now provide the ability to either use template building or write scripts that automate. This is a very good approach because, firstly, it simplifies scaling, meaning we can easily add more systems and tables to our process, which can grow to hundreds of tables. By creating and defining our orchestration once, we will actually be reusing it, ensuring consistency, and that the data refreshes as we expect. Error handling and retry policy, which is about responding to these events, right? What to do if a particular service doesn't start because, for example, Google is having a network issue. It happens very rarely, but it does happen. Cloud Run didn't execute, meaning one of the services replicating data. And what then? Well, then we should manage to retry it. We know that this is a situation that sometimes occurs, very rarely. So we can safely retry the task. Logging, monitoring, and tracing, which essentially means recording information about what happened, so that in the end we can see what's going on. What problems we had, how long it took, because this will help us optimize the entire pipelines and optimize the schedule. But with schedule optimization, it's not a single task. It's more like a relay race. We approach this from time to time because we optimize our resources, we optimize our solutions, so we see that over time we can accomplish certain things faster, and perhaps we can allocate more resources because we need to process more data. But there are also a few issues that are worth avoiding in building orchestration. Firstly, the orchestrator as ETL or ELT. I once saw an example in an Airflow DAG, which was a massive spider performing data retrieval, transformation, and verification. It did everything. It essentially performed the entire ETL. Because it's Python, remember? Someone decided that since it's Python, it's a cool tool and it shows graphs. Let's do everything in it. But after some time, when something needed to be changed, nobody really wanted to touch it. The same goes for monolithic workflows, meaning we don't build orchestration to manage 2 or 3 tasks and large tasks, but rather to work on something modular, something that is broken down into the smallest possible entities of the task, of the entire flow, to manage it safely and efficiently. Unnecessary dependencies, meaning we shouldn't overdo it with these dependencies. That is, it's great that we ensure the data is refreshed only when it should be, but let's not create unnecessary dependencies. That could actually delay the publication of our reports, which are needed. And finally, swallowing exceptions, which also relates to a holistic approach. We need to see what's happening. And the orchestrator is a good place for this because it becomes a central point for managing our task flows, our pipelines. So this is the point from which we can see what's happening. Transformation deserves a separate piece because it is usually the largest part of our pipelines. Here we have the most data processing. Here we have the most SQLs that need to be written to deliver this report. So for such a report to happen, we probably have 5, 10, 15 queries, right? To generate 1 data mart, 3 data marts, and then reports are created. This is the most challenging stage of orchestration because here we have to manage the correct order of executing these queries. To do this, we would have to spend a lot of time writing such a workflow, taking care of that order. Here, tools come to the rescue that are dedicated to this type of task, such as dbt data fonta, which is a tool where we write SQL textually, but we define the transformation itself without having to define these dependencies, because these tools take care of that themselves. We only define what we want to achieve. It's similar with tools like Dataform or AWS Glue, where we visually define our pipelines and what we want to accomplish. And these tools also ensure that tasks are executed in the correct order. This is a huge simplification, which will be evident in the client's case study. A huge simplification for the workflow, because we really only need to ensure that the processing is initiated at the right time. But we no longer have to worry about arranging the entire sequence of query execution in our transformation. How does it look with orchestration in the cloud? We have the typical benefits of using cloud resources, as we get unlimited possibilities when it comes to resource utilization, an unlimited number of resources available for orchestration. In an on-premise environment, if we wanted to do this, it becomes problematic because we start creating a separate architecture just for the orchestrator to function. It requires a number of servers to schedule tasks, have an interface, and so on. When it comes to availability, reliability, cloud providers offer high SLAs. So if we use such tools in the cloud, they are also covered by these SLAs. We have these tools available practically without interruption. And we have the security of the infrastructure. We don't have to maintain this infrastructure ourselves, which is important. Because the most popular tools today require a piece of infrastructure that needs to be maintained and scaled to be able to perform these tasks. And often we simply receive a form of service managed by the cloud provider. So in reality, we don't have to worry about anything. We just launch the appropriate tool. and it's similar with security. This is very similar to what Marcin mentioned in the context of data warehouses. And now when it comes to these tools, the king is one, and that is Airflow. This is the most popular tool. It has a huge fan base, although also some detractors. It is a tool with a very large community, extensive capabilities, a multitude of plugins, operators, and so on. It is written in Python, so if we lack anything, we get a wizard who speaks the language of snakes and writes us a script in Python. It is such a popular tool that every provider, every major cloud provider, offers it as a managed service. But not only that, there are also separate companies that implement Airflow as a managed service. So in fact, even without having the cloud, we can run such an Airflow. However, this king also has certain drawbacks. Firstly, it is not a serverless service anywhere. It requires underlying infrastructure that needs to be monitored and maintained in some way. Even when we use these cloud resources, it's not like everything will automatically scale and manage itself, because it requires some parameterization and monitoring of what is happening in this environment. With this king, it is also the case that it is very good when we are scheduling. It's more challenging to react to business events, because the whole idea of Airflow DAGs is that we schedule a task, and it executes at a specified time. Of course, we can create code there that observes certain business events. These are sensors, and we can react to this event. Nevertheless, it's not a direct reaction to the event, but we have to schedule it. With this king, it's also the case that it doesn't quite align with real-time pipelines. With real-time, it's also the case that it's hard to talk about orchestration, because in real-time, the data simply flows, and orchestration focuses more on orchestrating the service itself, meaning the resource for this service, rather than orchestrating the data. So what does the tool situation look like with these providers? From a purely orchestration perspective, there's really only Airflow. It's the only tool that is a true orchestrator, and it is available from each cloud provider as a managed service. Nevertheless, Airflow is good when we actually have large pipelines to orchestrate, when there are many tasks to perform, and we have a multitude of refreshes, a multitude of such flows, because it requires a certain amount of effort. It requires learning this tool. Therefore, it's not worth using Airflow when we have either very simple flows or only a few of them. And here we have alternative tools, for example, those that are more focused on creating data pipelines, but they are mainly limited to the cloud ecosystem of a given provider. They often have plugins that allow for integration, but it's not the same level as Airflow. These tools are perfect when we need to focus more on the data flows of what we already have. They are ideal for situations where we actually have very few tasks to perform. However, if we have a situation in the organization where there are very few tasks, because it's enough to just recalculate the model and refresh the data mart at the end, then we are really entering services that are simply dedicated to data flow, right? So we only define the tasks that need to be executed. We don't need dependencies. Perhaps in the organization, we have something like dbt. And our task is just to run dbt at the appropriate moment, because it's somewhat a bit monotonous with Airflow at cloud providers. Other solutions are appearing on the market. Of course, Airflow is still around because there is Astronomer, which is simply Airflow as a managed service externally, with support and maintenance of the entire platform. Nevertheless, other services are emerging that will try to dethrone this king. These are services that are already looking to the future. They allow us to build orchestration in a declarative way. So, we don't focus on writing what we want to do step by step, but rather we define the results we actually want to achieve. An example is Prefect, which is a more comprehensive tool. We can orchestrate not only data pipelines with it, but also various types, such as application orchestration. And Daxter, which focuses strictly on data, it treats data as assets. We actually define certain products that we want to process. So I'm keeping my fingers crossed for these tools, because for now at least, they are not yet visible in our market. So, a client case study. Since we've already talked about orchestration, let's see how it might look in real life. We have several companies that form an organization. They have shared systems, common data sources. Some are separate. These sources are usually either the downloadable files or relational databases, or in some cases, new databases. The decision is made on that it will be Google's ecosystem and the data warehouse will be BigQuery. And finally, an assumption that everything should be code-free on the client side. That means the client does not want to develop these pipelines on their side in any way. They want to receive everything solely through configuration files. So what solution did we propose? Well, of course, Composer. There was no other choice here. However, we enhanced it with a new database that allows us to strengthen this processing. Since we are managing many different services and often want to parallelize the launch of this service, we want to store the information needed for this. We provided a system configuration file, meaning the client actually defines, this is my database connection, this is the table I want to retrieve from this system. I want to put it in this place. There is a separate file, for example, also for transformation. This is my defined model in DBD in data form. It has such tags, then I want to run it. Based on such a configuration, we have a Python script to a point that automatically builds hook tags in Airflow. So this is precisely that automation. We wrote the defined flows once, and based on the configuration and its parameters, a file for Airflow is automatically generated, and the DAGs, so to speak, magically appear. And we have it broken down into several modules. So this is the modularity. We break down these pipelines so that tasks are executed on smaller modules rather than monolithic workflows. There are three parts to this. The first one is the data retrieval itself. So we have a scheduler that runs the task at a specified time. In the first step, what we do is verify whether we have already correctly completed today's task or not. Because Airflow is not intelligent enough to verify everything on its own. We have to tell it, let's verify. Because if we've already done it once today, then why should we do it a second time? Why generate those costs? So we verify such information. If we haven't fetched data for this table, then we start pre-processing, which means we verify what data we need to fetch, in what strategy, whether it's incrementally, or if we need to recalculate the entire table. If incrementally, we verify how many records are the source for fetching, because at this point we can talk about parallelizing this process. The orchestrator does this. It defines based on the configuration how many fetching processes we want to run simultaneously, or instead of one long-running database connection process. I am starting the pre-processing, and this is where the piece we added comes in, which is monitoring the logs we are storing. So we are not only relying on Airflow logs, but we are building this logic ourselves. And here we use the functionality of Composer, which allows us to simply wait until this information appears. This is the implementation of event-driven. We are waiting for the event, that we have this information. And then decisions are made. If these are connections requiring an API, then we have specific cloud functions, for example. So we have certain functions that fetch this data, and then we activate them. If it's a different type, we activate a different type of service. So the orchestrator decides in which case we use which service to fetch the data. Moving forward, we then store this data in Avro files. These Avro files end up in the data lake, sub1, and we appropriately set flags. So we have the entire flow of such a process. We have logged this information, and that's the end of it. Now what's next? Next, we process this data. For this, we have separate processes, separate orchestration. We have DAGs for transformation. Here we simply use data form. In fact, our task does two things. Firstly, we have these dependencies, meaning we monitor the appropriate tables from the previously shown DAGs. Have they been refreshed yet? Because if not, we don't start this process. If they have been refreshed, we start it at that moment.
The question is, if it's handled by us, can it be linked to the fact that the other process has finished? Or
Yes. Yes. Through the appropriate Airflow components, we look at a specific designated task. So we indicate which task it is. We can indicate we made, let's call it a certain bracket, meaning we enclosed a single table in start and end, and the entire system that aggregates start and end tables. Thanks to this, we are able to say whether we want to look at this table or the entire system. And it also works with configuration, because we only introduce into the configuration file what we want to look at. And the script automatically adds additional sensors that monitor these tasks. Moving forward, we simply run this transformation. And here we take advantage of the benefits of the data form, which takes care of what needs to be accomplished. We only appropriately initiate the code compilation and then the execution itself. In the data form, we also use this testing, meaning assertions. We define what the data quality rules are that need to be implemented, and it is here that we actually observe whether these rules are met or not. Because if they are not met, we can then decide from this point what to do next. And it is very similar in the case of reverse ETL. So we have a separate DAG, which also has its own configuration, where we indicate that we want to push this specific table to SFTP, to the package, to the PostgreSQL database. And here, the most important stage is really observing the dependency on other tasks. So here we look at whether the data is already ready. If they are ready, then we launch a specific service that is capable of pushing the data to the target location. What does it look like in the end? These are really the steps we are implementing. And we take advantage of the fact that thanks to dependencies, thanks to monitoring, the process is secured. And finally, what trends do we see in orchestration? Because today, it is indeed the case that there is this one Airflow, but it is no longer sufficient. Firstly, greater automation and low code, which essentially means moving away from needing a data engineer to build the entire orchestration and write a huge piece of code. We are moving more towards wanting to drag certain blocks and define what we want to accomplish. The development of event-driven orchestration. Indeed, it is the case that these tools require scheduling, but increasingly we expect our processes to respond to business events. So we don't just want to rely on starting a task and yes, observing something there. We want to genuinely react to something happening in the business. We have system information that this has happened, and we want to automatically trigger our entire data pipeline. Declarative orchestration, which is somewhat what these tools that go beyond the cloud provider stack have shown. We are essentially simplifying this way of life. We define what we want to achieve. That's exactly how data form works, for instance. We define the transformation we want to achieve, rather than defining all the dependencies step by step when it should be executed, because the tool itself manages that order. And we expect the same from orchestration tools, that we only define what results we want to achieve, and the tool will decide for us how the pipeline should be executed. And the last element is support for data mesh, for the data mesh architecture. There are more and more organizations struggling with these data silos. Often there are organizations that acquire other smaller companies. A gigantic technology stack emerges, and the headquarters wants to report on it. Today's orchestrators struggle with managing workflows in such an environment. This will be one of the bigger challenges facing orchestrators, as it is also an architecture that is gaining popularity and is strongly supported and emphasized, for example, by Google, which is actively promoting data mesh with its tools. And that's all I wanted to convey today. If there are any further questions, feel free to contact me.
Do we have any questions?
I have a quick question, Mr. Alexander. How does orchestration relate to the democratization of data in an organization, to the process of creating a data catalog?
Traditionally, it depends, right? Orchestration, if we design it well, will support this because it will deliver the key data where we need it. In reality, most of it depends on what kind of data we have and what their quality is, right? Are they available? The orchestrator will really help here to ensure that the data is properly delivered to the final places of data consumption.
Thank you.
Last question. What is Dataform? What is it?
Dataform is a tool that helps us build data models. So, in an extended SQL language, we define the transformations we want to perform. And Dataform takes care of properly executing that transformation and building the model. I would say it's an alternative to dbt within Google. Thank you.